here we go. Today we are talking about two new rules for taking derivatives. They are called the product rule and the quotient rule. So the product and quotient rule for derivatives. There are a lot more derivative rules that we're going to be learning over the next few weeks. Basically, the only main rule that we've learned so far is the power rule, how to bring the power down and lower the power when you take a derivative. This is going to teach you today how to take the derivative of two functions that are multiplied together and then turn around and show you how to do it when they're divided. So we'll start with the product rule. When I write these rules down, I'm going to write them as they are seen in a calculus textbook, and then I'm going to give you a way to help you remember them because they do have to be memorized, not to be necessarily written out in longhand, but to be used in a problem. Okay? So the product rule goes like this. D dx parentheses f of x times g of x equals d over dx of f of x times g of x. Now, what does this notation d over dx mean again? Derivative. Exactly. Now, it would be nice and easy if you took the derivative of a product, you just took the derivative of the first one times the derivative of the second one, but it doesn't work that way. With adding and subtracting, it does. You take the derivative of the first, then you add the derivative of the second, then the derivative of the third. But when it's multiplying, it's different. Here is the way the rule works. It is f of x times g prime of x plus g of x times f prime of x. So that is the product rule right there. F of x times g prime of x plus g of x times f prime of x.
Why?
It just works that way. That was the pattern that the mathematicians discovered when they would do them out the long way and went, oh, you could just do this, and it makes it go a lot faster. Okay? There is a big old long proof for it, but I'd rather not take the whole period doing it for you. Okay? All right, now, how do we remember this pretty simply? Well, what I'm going to do is I'm going to call this function 1 and function 2. Okay? So if you think of it in terms of the first function and the second function, this is the first function times the derivative of the second plus the second times the derivative of the first. Okay? And even more simply than that, I have a shorter way to think of it. When you see a function, I want you to give it its number name. But if you see the derivative of a function, I want you to put the letter d in front of it. So this one happens to be 1, and this one is d2. 1 times the derivative of 2, 1d2. Plus, what would the second part of the problem be? 2d1. 2 times d1. So if you don't say the word times, it's understood. 1d2 plus 2d1. That's not very hard to remember. 1d2 plus 2d1. After you've done it a few times, it's pretty simple. Okay, 1d2 plus 2d1. First times the derivative of the second plus the second times the derivative of the first. Okay, now, here's an example of the product rule in action. Y equals, parentheses, x squared minus 3x plus 1 times 7x to the third minus 2x plus 5. Okay. I'm going to take the derivative of this using the product rule. But I want to say this first because this question was asked last period. Someone said, well, why don't you just FOIL those two out and take the derivative the way we know how? I could, but I want to demonstrate the product rule, and with the kinds of functions that we know right now, these are the only kind of functions that we can use. Okay? So we're going to call the first parentheses function 1 and the second parentheses function 2, and we're going to follow the pattern. So when you take the derivative, y prime equals, first thing you do is copy 1 down. So we're going to copy the first parentheses, x squared minus 3x plus 1. That's the 1 step. Then I want the derivative of 2. So the derivative of the second parentheses. And that would be what? 21x squared minus 2, close parentheses. So I have just done 1d2. Now I'm going to do what? 2d1, right? 2d1 is the next step. So plus, now copy 2 down, 7x to the third minus 2x plus 5 times 2x minus 3. Agreed? That's 2d1. So you understand the process of copy the first, take the derivative of the second, copy the second, take the derivative of the first. Now, I need to clean this up. Okay? So we'll take the 1d2 part right here. I'm going to multiply x squared to both of those in d2, then the negative 3x to both of those, and the 1 to both of those. So let's start with that. You're going to take the whole line, I promise you. Y prime equals. I'm going to see if I can squeeze it in there. So x squared times both of the d2 numbers. So that'll be 21x to the fourth minus 2x squared. Now I'm going to cover up the x squared so I know what I'm going to next. So negative 3x times both of those. So that'll be negative 63x to the third plus 6x. Done with that. So now I'm moving over. Now I have 1 times both of those. So plus 21x squared minus 2. So that's multiplying 1 times d2. That's done. Now I got to do the same thing with 2 times d1. Plus, here we go again. You don't have to because it's all added. You could, but you don't have to. 7x cubed times 2x would be 14x to the fourth. 7x cubed times negative 3 is negative 21x to the third. Done with that, so cover it up. So negative 4x squared plus 6x. Cover that up. So plus 10x minus 15. Squeeze it in there, and I did it. Got it on one line. It's a miracle. It is. Okay. Give you a chance to catch up. Excuse me. 10x minus 15 is the last two terms. Okay. So, final answer. Collect like terms. Y prime equals. What's the highest power you see? 4. So I got one here. There, they're both positive, so 35 x to the fourth. That takes care of the first one. Lightly mark those out. X to the third. Got one here and here. That's negative 84 x to the third. Mark those out. X squared. Negative 2, 21, negative 4. So negative 2 and negative 4 is negative 6. 21 is positive 15. X squared. Mark those out. So 6x, 6x and 10x. 12 and 10 is 22. So 22x plus minus 17. And I'm done. Okay? Now, statement has been said before that says that calculus is, the class of calculus is about 10% calculus and 90% algebra. After doing that problem, do you kind of understand why they say that? How much calculus did we do? Just a little bit. The majority of the work was right here in cleaning this mess up, wasn't it? And what happens if you make mistakes in here? Totally throws things off. You may totally understand the process, but mess up in the cleanup. That's why it's kind of a pain. Okay, let's go on to another problem. Y equals, this one's not quite so bad. This one's not quite so bad. The cube root of x times 3x to the third minus 9. The cube root of x times 3x to the third minus 9. We are going to use the product rule to do this problem. Now, I only see one parentheses. However, this term out front is the first function. The parentheses is the second function. But I need to rewrite it to put it in the proper form so that I can take its derivative. So y equals What is the true exponent on the cube root of x? 1/3. Very good. Times 3x cubed minus 9. Okay? Here is function 1. Here is function 2. I would like you to do the first step by yourself. 1d2 plus 2d1. See if you can do it right now. Y prime equals. You try the first step. One d2 plus 2d1. Don't try to clean it up, just do the first step. Don't clean it up, just wait. Compare with the people at your table and see if you're getting the same answer. Okay, let's come back together, please. Shh. Look up here. See if this is what you got. Shh. 1d2 plus 2d1. Fixed it. Okay. All right. Now we need to clean it up. Y prime equals. These two right here need to be multiplied together. Okay? When you have like bases, when you have x to a power and another x to a power, what do you do to the exponents? You add them. You add the exponents. So, 9 is the only number. What is 1/3 plus 2 as an improper fraction? It is 7/3. 2 1/3 is 7/3. Plus, that takes care of the first terms. Now here, I need to distribute this and this both to this. Okay? So 3 times the third is 1. Okay. Look here. You have x to the third times x to the negative 2/3. We're adding them together. So adding a negative is the same thing as really subtracting. What is 3 minus 2/3?
1/3.
Okay, some of you are already saying 7/3, and you're right. But those of you whose brains don't work quite that fast, 3 minus a 2/3 is 2 1/3. Okay, think pizzas. I always think pizzas. 3 pizzas minus 2/3 would be 2 with a third left over. Make it improper. 7/3. So x 7/3. Okay. I'll be honest with you, my brain does not work that fast. Okay? No, I can't. No, seriously, I can't do math in my head. Okay. Now, 9 times the third. Negative 3. And that's the only x. So it's x to the negative 2/3. So you just copy it down. Okay? Now, can I subtract these two right here? No, because they don't have the same exponent. What about these two things right here? I can add those. So y prime equals 10x to the 7/3 minus 3x to the negative 2/3. And now I want it back in radicals. Now, for those of you who still struggle with knowing where to put stuff, let me show you. Step 1, write the coefficient down. Write the 10 down. Then look at the x and decide whether it goes on the top or the bottom. Where does this one go?
On top.
On the top. Why, Will?
Because it's numerator is denominator.
No, that's not exactly why.
Because it's positive.
Because it's positive, exactly. So it goes right next to the 10.
I'll see if Michelle knows.
Power over root, so the power is 7, the root is 3. So that one's done. Minus, write the 3 down. Look at the next one. That one goes where?
On the bottom.
On the bottom because it is
Negative.
Thank you very much. Over, draw your radical, put the x in it. Now because it's on the bottom, it's not negative anymore. So you write a positive 2 power, positive 3 root. That is the answer right there. Okay? Questions? Okay. This is the product rule. This is how it works. 1d2 plus 2d1. Now I need to teach you the quotient rule. Quotient rule is used for quotients, which are division problems. So, is everybody done with this page? Can I move on? All right, page 2. Moving down. Quotient rule. Okay, you realize that everything you were saying is being recorded. So, ddx of f of x divided by g of x. How to take the derivative of a quotient. Two functions that are divided. Now, this formula is a lot more complicated than the last one, but I do have a way to help you remember it. First of all, it's going to be a rather large fraction. So I'm going to draw a big fraction bar. The derivative of a quotient is as follows. You start with g of x times f prime of x minus f of x times g prime of x. All over parentheses g of x squared. That is the quotient rule. Now, you have to remember how that looks. And that may look a little bit, but I have a way to remember it. Several college professors use this. High school teachers use it as well. Instead of calling these 1 and 2, I'm actually going to call them high and low. High being the top of the fraction, low being the bottom, because it's very important that you don't get them confused. On the last one, 1 and 2, it really didn't matter because it was added. But because this one's subtracted, it does matter. Okay? Now, like we did before, I want to say what this one is using the words low and high and the letter D when you take a derivative. How do you say this? What would it be with use? Low D high. This is low D high. That's how you say it, low D high. And honestly, a lot of students, when we start say, I'll come up to your desk and say, okay, how do you do this problem? You'll say low D high. Just like when I come to your desk and you have two fractions that need to be added and I say, how do you do this? You say smile. You just know that's what it is. This is called low D high. Most people call this low D high. Minus. What's the second half? High D low.
All over low squared.
All over low squared. Okay.
Low squared.
Okay, so this is low D high minus high D low over low squared. Low D high minus high D low over low squared. Okay, that's not hard to remember. It's kind of silly. Silly stuff is what sticks in your brain. Low D high minus high D low over low squared. I will go ahead and mention this. If any of you happen to work with friends that happen to be Mr. Giglio's class, they do this slightly differently. They don't call it high and low. They call it high and ho, like high ho with the 7 dwarfs. Okay, high ho, high ho. And they don't call this ho squared. They call it ho ho, like your Santa Claus. Okay, so we call it high and low. They call it high and ho. It's the same thing. So if they're saying high ho, you realize it's the same thing we do. But I like low because low means bottom of the fraction. Makes sense to me that way. That's the way I learned it. She learned it that way, so that's the way she teaches it. Okay? So, let's practice one of these. Example, y equals 6x minus 3 over 2x plus 5. 6x minus 3 over 2x plus 5. We're going to keep it simple. Okay? We'll do this one together. Y prime equals, draw a big fraction bar. Okay. Do you think it matters whether I go high D low first or low D high first?
Yes, it does.
It does matter because of the subtraction. You must start low, low D high. So we copy low, which is 2x plus 5, times D high, low D high. What is D high? 6. So just the number 6. Minus, copy high, 6x minus 3. What is D low? It's just 2 over low squared. So we just did it. Low D high minus high D low over low squared. Okay. I said something earlier this year, and I'm going to say it again. Never, 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 never mess with the bottom of the fraction. That is as simple as it gets. Okay? The top, however, these two terms. I need to clean this up. I need to distribute and collect like terms on top. Don't mess with the bottom. Only mess with the top. So y prime equals. We're going to distribute the 2x and the 5 both to the 6. So that's 12x plus 30. Now for the second part, be very careful. And a 2, both. So 6x times 2 is going to be negative 12x. And then what? Plus 6. Very good. Over 2x plus 5, the quantity squared. Okay. Now, what's the numerator going to be? What happens? The x's cancel. They don't always cancel, but in this case they do. So I'm left with 36 over 2x plus 5, the quantity squared, and that is the derivative. Okay? Questions on that? That wasn't too bad, was it? No. Okay? Next problem. Y equals x squared minus 3x plus 2 over the square root of x. X squared minus 3x plus 2 over the square root of x. Okay? Now, the worksheet you just turned in to me, worksheet 1 on derivative rules, you had some problems that look like this, didn't you? Didn't you have problems with x's on the bottom? And I hadn't taught you the quotient rule yet. So, what I'm pointing out here is to know whether or not you should even use the quotient rule. This one, I had no choice. I had to use the quotient rule. Why? Because there are 2 terms in the denominator. If there is ever more than one thing on the bottom, you have to use the quotient rule. I can use the quotient rule here, but there's an easier way to do it. Not exactly. Does anybody remember what we did to this? You separated into separate fractions. Now, like I said, the quotient rule will work here, but it gets kind of ugly. So, when you're doing a problem, and a lot of times your brain is going to say, oh, fraction, quotient rule, let's go, and you start working the problem, and then it's turning into this really ugly mess. Okay? If that happens, go back and look and see if there's only one term on the bottom. Because if there is, you can break it into separate fractions. It's going to be a lot prettier. So we're going to do this one. Is this one quotient rule? In this case, no, this one can be separated. Okay. You can use quotient rule or you can separate it. We're going to go ahead and do this the separating way. X squared over the square root of x minus 3x over the square root of x plus 2 over the square root of x. All right. Now, this is still y, not y prime. When you have x as top and bottom of a fraction, what do you do to the exponents? Add, subtract, or multiply? You subtract, okay? Now, what exponent is on that x as it sits in the denominator? 1/2. It's not negative because I didn't move it. Still sitting on the bottom as a 1/2. So it's 2 minus 1/2 is what? 1.5. Make it improper. 3/2. So that's how you clean up the first term. Okay? Minus, bring the 3 down. The numerator's x has a power of 1. The denominator's x has a power of 1/2. What's 1 minus 1/2? 1/2. So x to the 1/2. Plus, write the 2 down. This x on the bottom has nothing to subtract from it, but I do need to move it up so I can take its derivative. So I write negative 1/2 like so. Okay, now, your turn. I want you to do the next step. Do the next step for me. Practice taking those derivatives with those exponents. Okay, I've written it up here. If you're done, take a look. Is this still hard to do? Some of you still struggle with this. Okay, let me walk through it step by step. First of all, the 3/2 comes forward. 3/2 minus 1. If fractions kind of mess with your head, change them to decimals. 3/2 is 1.5, right? What's 1.5 minus 1? 0.5, which is 1/2. So that's why this one's 1/2. Bring down the 1/2 times the negative 3 makes negative 3/2. 1/2 minus 1. 0.5 minus 1 is negative 0.5, which is negative 1/2. And now negative 1/2 times positive 2 is negative 1. Negative 1/2, negative 0.5 minus another 1 is negative 1.5. That's why it's negative 3/2. So that's that right there. Now, to do the last step, to put it back in radicals, put the 3 over the 2. X goes top or bottom. This one goes on the top, so it's square root of x minus 3 over 2. Where does the next x go, top or bottom? On the bottom. Square root x, 1 and 2, minus 1. The last x goes bottom also. What's its power? 3. Root is 2. That one's done. Questions?
So you're just finding the derivative?
Uh-huh. Found the derivative. It's ugly, but it's the derivative, I promise you.
She's smart. She's got it, man. Yeah, really good.
Okay. I have one more thing to talk about. It's not very long. And that's, we've done the notes of the product and quotient rule. Now we're going to do horizontal tangents, which we've already talked about, which means it's going to go a little faster. Is everybody done with this? Thumbs up? Good? Okay. All right. Okay. This comes into very important play now, even more so than before. What's so special about a horizontal tangent as far as calculus goes? Anybody remember? What is its derivative? Right. When you have a tangent line that looks like this, that actually touches the curve, what is its derivative? It's 0, right? Because derivative means slope, and isn't the slope of a line that looks like this 0? Okay. It is a tangent line to a curve whose slope or derivative is equal to 0. Okay. In your homework, you're going to have a question that looks like this. It's going to say, determine the points at which the curve has a horizontal tangent. Determine the points at which the curve has a horizontal tangent. Okay. Let's not get horizontal tangents confused with horizontal asymptotes. An asymptote is a line that a graph gets really close to but never gets to it. A tangent actually touches it. It actually touches the curve at that point. So these are not the ones dealing with limits of infinity. Okay? Now, what I'm trying to teach you throughout this course is as you do a problem, when you see a phrase, to know what to do with it. We've done a lot of equations of tangent lines lately, haven't we? And what do you always have to do with an equation of a tangent line? You have to find a point and you have to find a what? A slope. Okay? With a horizontal tangent, whenever you see that phrase right there, you need to know that that means take the derivative and set it equal to 0 every time, because that's the definition of a horizontal tangent. So when you see the phrase horizontal tangent, you take the derivative and you set it equal to 0. Okay, y equals x squared over 3x squared minus 5. Okay, so this is the curve that we want to find where the horizontal tangents are. So we're supposed to take the derivative and set it equal to 0. Here's my question. Do I have to use the quotient rule? Yes. Why? I have two terms on the bottom. I have to use the quotient rule. So here is your turn to practice. I'm actually going to walk around the room this time. I want you to use low D high, the quotient rule, to take the derivative of this. But what I'm going to do is I'm going to put my paper back up here so you can see the low D high right there, right up there. Try that problem right there. See if you can take its derivative. When you're done, raise your hand and I want to come see it. There you go. That's exactly right. Okay. So, y prime equals low D high minus high D low over low squared. So we get y prime. Okay, this is another thing I need to bring up to you guys. Some of you are getting sloppy with your calculus, and it's really important that you label stuff. When you start taking derivatives, I better see a y prime equals there. I'm going to take points off, and I better see it on the final answer when you're done. Very important that you do that. 6x cubed minus 10x minus 6x cubed over 3x squared minus 5 quantity squared. Those two cross out, so you get negative 10x over 3x squared minus 5 the quantity squared. My y prime is right there, showing that that's the derivative. Okay. Now, the question says find where the horizontal tangents are, which means set the derivative equal to 0. So negative 10x over 3x squared minus 5 the quantity squared equals 0. All right. Question of the day. Do not say the answer out loud. I want you to think about it. When you're setting a fraction equal to 0, do you set the top equal to 0, the bottom equal to 0, or both? Don't say it, just think. Is it the top, the bottom, or both? And why? That's an even harder question. Okay. Does anybody want to volunteer to tell me which one and why? I'm going to start with Tyler. Why?
Multiply the denominator with 0.
Okay, because you multiply. I think I know what you're saying. Can you elaborate? What do you mean you multiply the bottom by 0? When you do what? You don't know? Okay. Okay, I think I know what you're saying, but I don't want to give it away. So I'm going to ask Kyle.
When you set the bottom equal to 0, it doesn't have to be the vertical asymptote. So you set the top equal to 0.
Okay. How do the rest of you think? Is that a valid answer? Doesn't setting the bottom equal to 0 give you vertical stuff? Yes. And I'm looking for horizontal stuff. So it is set the top equal to 0. Does anybody have another reason why we set the top equal to 0? Yes. Setting the bottom equal to 0 makes something undefined, doesn't it? Because isn't when the denominator equals 0, isn't that when it's undefined? Yes. So we only set the top equal to 0. Only. Good answers. Very good answers. So negative 10x equals 0. Gosh, that's hard. Wish all of calculus was that hard, right? So x equals 0. Now what I think Tyler was trying to say, and I'm going to go back and talk about that, because this is the way I used to teach it. Isn't 0 the same thing as, say, 0 over 1? Okay? And then if you cross-multiplied, you would multiply 1 times negative 10x, and you get negative 10x, and then you multiply 0 times the bottom, which would be 0, which would make the bottom go away. So that's kind of what I think you were thinking. Yeah. So you get x equals 0. Now, did I answer the question? No, because it says I want a point, so that means I want an x and a y. Okay, here's the second question of the day. Think about this one. In this case, I would get the same answer. But in other cases, should I plug the 0 into the derivative or into the original equation? Don't say it, just think. Do I plug the 0 into the derivative or the original equation? Raise your hand if you think you know the answer and tell me why. Jordan, go. Very good and very well said. I'm going to say it again so that it's audible on the camera. You plug it into the original because if you plugged it into the derivative, you would be getting a slope, not a point. And this one says y equals. Are you looking for a y value? Yes. So you want to plug it into y equals. So when you plug 0 in there, you're going to get 0 over negative 5, which is 0. That's our final answer. Very well said. Any questions? Okay, I am going to stop for the day right there.